Artificial intelligence is moving away from point-to-point conversations. New systems are now capable of mapping and navigating complex data environments without human input, evolving into autonomous decision trees. Previous models were limited by the physical constraints of their memory. Because they relied on short context windows, they were unable to maintain focus on deep, multi-stage problems for more than a few hours. Anthropic's Mythos class bypasses limits with a 10 trillion parameter architecture. Hierarchical memory keeps millions of tokens active. This allows an agent to hold a 50 million line codebase in memory, processing entire systems at once, or rebuilding applications from raw pixels. Shifting from a reactive assistant to an autonomous agent changes the logic of digital infrastructure. It forces a rewrite of how human work is managed and how systems are engineered. This shift introduces a core dilemma. The reasoning required to solve the most difficult problems is dual use. The intelligence is inherently dangerous. In life sciences, biological reasoning to design therapeutics is the exact same logic required to engineer a bioweapon. They merge into a single node. In cybersecurity, untangling legacy code requires identical capacity to chaining autonomous exploits. Because these beneficial and malicious functions rely on the same mathematics, they cannot be separated. The raw model is too risky for a general release. Anthropic's solution was to split the model's reality into two distinct ecosystems, rather than reducing its overall capability. They created Mythos 5, the unchained version of the model that is strictly locked away from the general public. Through a program called Project Glasswing, access to Mythos 5 is limited to government cyber defenders and highly vetted life science researchers. Inside this secure vault, the model has accelerated drug discovery by 10 times. It can choose binding sites and run protein design tools autonomously, matching the output of a skilled scientist. The cutting edge of artificial intelligence is now a closed ecosystem, creating a divide in who is permitted to use frontier power. For everyone else, there is Fable 5. It holds the same raw intelligence, but operates inside a cage of classifiers, monitoring cyber, bio, and distillation risks. They scan prompts for restricted topics, blocking them before they reach the model. When a risk is flagged, the system executes a silent fallback. Fable 5 reroutes the query to a weaker, safer model, like Opus 4.8, which handles the response instead. This creates a unique friction for developers. The API returns an HTTP 200 code, a signal that usually means success. If an automated pipeline isn't programmed to inspect the reason for the refusal, it will treat the fallback as a valid answer and fail. Companies adopting Fable 5 must also accept a 30-day data retention policy. This policy applies to all traffic, effectively ending the zero data retention privacy that many industries rely on. Access to 10 trillion parameter intelligence now requires engineers to architect their systems around censorship, silent fallbacks, and data compliance. At double the cost, Fable 5 is too expensive for everyday tasks. Businesses use tiered routing, sending only their most complex problems to the frontier model. It becomes a strictly defined escalation tier, reserved for intractable problems where the reasoning depth justifies the price. We see this escalation in software engineering. Stripe used this capability to autonomously migrate a 50 million line codebase in a single day, a project that would have taken a human team months to finish manually. Success in this landscape depends on both access to the model and the mastery of the operational routing that determines when to use it. The release of the Mythos class shifts the industry focus away from raw parameter counts. The new arms race is about governance. Companies are now judged by how they balance autonomous capability against the need to mitigate catastrophic risk. As the physical map of the industry burns away, a new frontier is revealed: the mapping of vast, heavily guarded neural architectures. The challenge of the frontier is no longer building an autonomous mind. The challenge is deciding exactly how much of it to unleash.